Okay, we are live. So, it's Corey and the other day working on lesson 10. We may decide just to stop the broadcast later, just because we can focus on the work. But we are meeting today. So, let's go ahead and lesson 10. So, inference for 1 mean sigma known confidence interval. Lots of fancy stuff.
Really fancy. This one is learn how to calculate marginal error.
Okay. Yes, meet. Yep, we're both here. I really don't like this. I wish this would pull up here so you didn't have all this.
Smaller, make it smaller. Zoom in. Zoom out. Yeah, one more.
Okay.
That's actually smart. Putting your sticky notes.
Oh, yeah. And also, I can't put an entire stack, but
That's enough.
yeah, about 8 to 10 at the most. And then, oh, I need to know. Okay. Okay. So find the margin of error for a 90% confidence interval when the standard deviation is 50. Equals mean.
Marginal errors formula is there are 7 summary. You type summary, 7 summary to find it.
Equals variance. So it is. So the margin, it's asking for the margin of error. And find the margin of error, which is.
Error is Z. So Z represent calculate Z score correspond to a particular confidence level, and then Z score times what's that called? Standard deviation divided by sample size square root.
Okay, Z square times deviation. Okay, so stop back here. So we have standard deviation. Okay, so we have the standard deviation in. So how do we get the Z score though?
Wait, it says
Or is
marginal error is already 90. Wait, marginal confidence is already 90, so marginal error should be 10, right?
It's not going to the confidence interval.
Oh yeah, 3 decimals. That's also not reliable as well. Let me search marginal.
Okay, so the confidence interval, it's the one below that. Gives us the mean. Do we have the mean? So the deviation. Oh, okay, how do we do that?
Confidence.
Let's come up here and try to explain some more. Although if you scroll up on the right here, well, I'm wondering, but I don't know if that's for all things or just this instance.
Yeah, I think that's for just for example.
Okay, so Okay, so we use, so the confidence is the total area underneath, and then from that you get the z-score.
C.
Okay. And so we can still use that thing. So the z-score would be 1.645. So confidence level is z-score. Box. Okay, so it's z-score for this one. No, it's super tiny. 1.6. 1.45. Okay, in the end, what was our sample size that they gave us?
Sample size is 25.
25, and they gave us, and the standard deviation 50. Okay, so we got that. We have all that stuff that we need. So the equals. Let's see. Let's see. Let's see. Standard deviation, which is 50. Divided by square root of
6.
So double conversion. See, close all that. See. This was, what is it? This is our confidence interval? Or no, this is our
Margin of error.
so 16.45.
Third decimal. Three decimal. Let me do it by hand. See if that got something.
So it comes out to 6.450 if you start adding all the decimals. So
Interesting. Let me see. So is area means is the marginal. And then we got a z-score. Okay, z-score, standard deviation. Okay, I see. So 1.645 times the thing. Thing is 50 divided by 25 square root. That divided by 5. 50 divided by 5. Yeah, I got something.
okay, so
Which spy statement is true?
X is new, yeah. S is standard deviation. Does it show that? Show any more of those? It's not showing that. Okay, so oh, it's asking which one's true.
Mhm.
Oh, okay, I was thinking which one's smallest. Well, that's it. So the mean, or the x bar is a point estimator for mu. Okay, so we have a deviation, we've got a sample size, and a 95.
The confidential interval is an interval estimator used to give range of possible values for a millimeter. The width of a confidence interval depends on the chosen confidence level. And it is corresponding value of z score, as well as the sample size and size allows us to use that in order to acquire specific errors.
So we're at estimate. The formula for the point estimate.
You figure out the number of questions already?
3,
The one, yeah, no, 4.
4, yeah. So x bar. So mean is the point estimator of
Oh, you know that.
point estimators.
Mhm.
And it talks about it more down in here.
Oh.
Here's left side. Okay. Estimate.
Wait, so the short answer is that we never know for sure if x sample mean is close to population mean. This doesn't mean that we are helpless. The law of population normal distribution provide a way us to create a range of plausible values of per meter based on statistics. Okay, I see how it means.
So, and if it's not that one, then it's the one below it. So,
No, the one below is opposite.
Yeah.
So it shouldn't be. Initial estimator interval is a range, so it shouldn't be any value. So it should be the one. So but which, even though in statistics that's not like definite sure, it's just an estimate.
okay, so n is 60. Deviation.
There's a point estimate is right on there, right?
27.685.
Question number 5 is 526, right?
Yep.
Mm-hmm.
And then number 6 is 27.685. So all I did is I changed the numbers in here for the formula. Automatically adjusted the. This is asking for the margin of error.
That's right. Yeah. What was it? 7.685.
Lower limit of the confidence interval.
You just this marginal error. It should be this one. The negative and plus the lower limit, so
So what is
it should be the mean minus the number you calculate. It should be, yeah. 526 minus 27.6.
25 for tax. Confidence intervals from that. Okay, so our sample size is 64. This is 113. Okay, so how did they get?
Same number without.
Okay, so there's that number.
The bottom two just like plus or minus that number, that confidence interval. That's it. That's what the number I got exactly.
Okay, so it was, so they took 526, they took the mean and subtracted and or added the, so they subtracted
The margin of error.
that one, the 27.
And that's the number I got. And
Okay.
3 decimal places to the two numbers.
Okay, let's try it. Okay, so then the lower one would be
498.
and the upper one, you just add that, which would give us 3.685. So what would happen to the width of the confidence interval if she increased the sample size? So let's find out sample size is n.
Give me like 1,000.
The marginal interval goes down. And that's what you subtract. So,
Yeah, good. Margin of error should go down if the sample size goes up.
confidence. Or what would happen to the width of the confidence interval?
Go bigger. Because you're more confident of your sample, basically.
Yeah.
But that's
Okay. So what happened to the width of your confidence interval? This is why I think, hey, wait, what is it that we're actually? So we're pulling more people, so we know our results are more accurate. So our width, because our confidence interval, the normal probability, it's this area in between.
Yeah.
And so if we take a sample size,
That's not sample size though.
yeah. But so if we were to take a bigger one, though, we're saying our confidence would increase. So instead of being a 90, ooh, around 98. So the width is increasing.
Logically, that's right, but I'm not sure if the area will increase. That's another thing.
Because this is, it's, I'm assuming it's measuring the width from here to here, the width.
So we just need to make sure the area, which is the probability of our confidence interval, will increase. That's the thing we need to make sure. It might be not change because I remember that the confidence interval is something that you set for. Yeah, it's the chosen confidence level that you choose. It's chosen. It's not like depending.
So this is increase. So if the sample size increases, assuming everything else stays the same, the sample size increases, the width decreases. Okay. So it's not, so that's not the representative of,
But why? I don't know why. Let me see.
so if I guess I'm trying to, so say I want to know, okay, do BYU Idaho students like pizza? And I go poll 2 people, how confident can I say that I can give an accurate percentage based, or even if I just do 100 students out of the 30,000, is how confident can I be in my number? I'm gonna, my ballpark range is going to be, okay, it's going to be somewhere between here and here. As I ask more people, and that's what we showed in here, when we increased it, you got the marginal errors also decreases. So if I go and I ask more people, so if I say I survey 10,000 students and they all respond, I'm going to be able, my accuracy of my prediction is going to be higher, and so I'm going to have more confidence in the number because I've surveyed more. So my, okay, it's going to be within here. I have,
Yeah.
instead of it could be, from here, here's kind of ballpark.
That logic I understand. That logic I understand. You know what this word means. Yeah. Converter interval, but like, doesn't that mean that your converter interval should be even more confidence? Oh no, because the converter interval means that you are confident between these numbers. Like my statistics shows that between this number, this should be right. And so if
It should be right, 98% of the time it's going to fall in between here versus
here.
okay, 98% case going to be in here. I don't know. If you feel confident saying something's going to happen 98% of the time, okay, 95% of the time.
Actually, no, not 95%. The 95% you're doing right, but it's like, oh, I have 95% confidence that the number will be falling between these 2 numbers. But if you have more sample size, this 2 number will be closer.
Yes.
This range will be smaller,
Yeah.
but it's still 95%.
Yeah, that's still 95%. I'm saying in terms of the change in percentages, and then doing the sample size increasing. Okay, I know 98% becomes this, then becomes this.
So it should keep going. So right. Why did the confidence change to a 99%? So that will be no change because the 99 is something you choose to decide what marginal error you want. It will not affect the statistic results because the sample size has not changed. What is that called?
So this would, so from here it says that it's going to increase. So increasing the confidence level would lead to a larger value of z. If z is increased, the margin of error would also increase. This would lead to a wider confidence interval. So, okay, so if we increase that, our z score is going to increase. So we can come here to the Excel, we'll set this back to, what was it, 64. So assuming that stays the same, we change our z score from 9.6 to 2.5. It went up, and then go up to 3, it just keeps getting bigger.
Oh, why? I mean, you change your, what is that called?
So here's, if you look at the formula, so so each time our z score goes up, and we're looking at the formula here, if I'm multiplying instead of by 1, I'm now multiplying by 2
I understand
or by 3.
formula. I want to understand behind the logic. Like, what you're talking about formula that something that I instantly got it, but I want to understand why. What the numbers, the formula is telling me, the story. So it says that what is the 95 and 99 means here? It's a confidence level. Confidence level Confidence level means that I will be good if I'm at 95%, if I'm 95% accurate. If that's what it means, confidence level.
So let's go back up here to the specific definitions.
Level. Okay, about convenient. Number 95. Okay, most of the time, researchers report live by confidence in confidence intervals. Number 95 is called confidence level. Confidence is described using the level of confidence that is different from that.
So the confidence is basically, it's really a, from here, so it's a probability that it's going to fall in between. So if I have a 99% confidence level, it's going to be 99% chance it's going to fall between
This area.
these two numbers.
Okay, so because the confidence level increase, there
So I have a higher percentage of,
to fall in this place means that it requires a higher accuracy to catch this 9%. Means the confidence width need to be bigger to catch the 99%.
yeah.
That's what the formula.
That's why it's going bigger.
Yeah, that's why it's going bigger. Okay. Cool. It's like a sniper. You need to zoom in.
Okay, so you said it would increase.
Yeah. Increase. How much chance you hit this guy? This is interesting.
Okay, so right bulb. Study that. Light bulbs. So the standard deviation is 400 hours. So let's say that 400. On a 95 confidence interval with margin of error of 50. So let's do that. And they want to know what n is. So anyway, okay, so we have, so this equals, and so we have m of the standard deviation. We need square that, square that, square that. There's probably a formula underneath there. I should put you on. If I engineer this, it's asking for the sample size. Oh, do I have to do I maybe need to reverse engineer this?
You just need to learn to not that part though. Do you have the marginal error? Here? Oh, there you go.
Sample size calculations. There we go. Yep. So you square that, you square that, you square that. Yeah, so they do have the formula right there.
So just same thing.
Yeah, just a lot faster than that. Okay, so n equals z times standard deviation over m squared. Okay. So let's put this into this. So this n equals z. Top one is z times standard deviation divided by margin of error. Let's see, then we square all of that. And do a mixture.
The Excel fix it for you. Don't worry.
Oop, right. 576.
So far.
And they want it. Let's make sure that's investment places. Okay, and that's right on money. 576. Okay. Why they're sticking out? Okay, 76. Size is 36. 36. Thirty-six, 730. Don't have the z-score. That's what this is, right?
No.
No? There's
You have the confidence level.
so if I'm looking at Susan number 12.
No, you have confidence level.
Okay, we do have that.
It is useful for you. Wait, give me a second.
This is 165.
No, it's 95, so it's different.
Oh, 95 times 90. So it's 196. And that just blew up in our face.
Make wider. Too big. Sample size too big. Actually, no. They are talking about million,
Okay.
10,000, 100,000 here, so it should be right. No, that's a little too big.
Yeah, it's more than it.
If you collect sample random,
So what is the I can't remember, what does that stand for? I can never remember what half these things mean.
hypothesis test significance is like marginal error. Marginal error, yeah, significant. So if the marginal error is greater than the null hypothesis is left like this to deny it.
My stat symbols down here. Deviations. Okay. What is X bar, is that the population mean? Maybe that's what I'm getting mixed up with.
No,
Or is X bar and that the same?
X bar is sample.
Sample mean, okay. And
Population means that.
that's the population mean is the mu, right?
That's mu.
Yeah, that's mean. Okay. And let's see the other one.
Alpha.
Significance of confidence level.
So 1
doesn't-
minus alpha equals confidence level equals 95% confidence level. So alpha also equals margin of error margin, margin of error. Yeah.
Okay. And I'm sticking up. Okay, and then I'm gonna go to stop. It says, I'll keep working on it. So I don't have to have this broadcasting the whole time.